The University of California, Irvine, a partner in DOE's Better Buildings Initiative, has been ranked among the nation's best universities, noted for its excellent science and research programs. With more than 30,000 students, it is one of the area's largest employers and includes some of the most energy-intensive and complex laboratory space in the world.
I'm Wendell Brazzi. I'm the Administrative Vice Chancellor at University of California, Irvine. I'm also co-chair of the University of California's Global Climate Leadership Council. We work with a number of faculty every day who are very concerned about achieving global climate solutions quicker, and we think energy efficiency is the first step in this process.
The university reached its Better Buildings goal through its SmartLabs initiative, a program to demonstrate how deep energy efficiency measures can reduce a laboratory's energy use by more than 50% in newly constructed or retrofit facilities.
Here we are at Natural Sciences 2. This is the building featured in the Better Buildings Challenge. This is just one of more than a dozen laboratory buildings that have been retrofitted with the SmartLab initiative. And it was that initiative that really enabled this campus to achieve the goal of the Better Buildings Challenge of reducing energy use per square foot 20% by 2020. We actually achieved that 7 years early. And because of that, we made the commitment to do another 20% by the original goal in the program, which is 2020.
SmartLab pioneers focused on 7 essential SmartLab components. All 7 must be implemented together to achieve the goal. With smart air management and ventilation systems in place, UCI was able to lower the velocity of air supply and exhaust systems.
These are this building's low pressure drop deep pocket filters, where the energy efficiency starts at the very moment air enters this building. Having a variable speed drive on the intake fan is an important part of every smart building because it's what allows the building to be dynamic. Here it says right now this fan is running at 55% of its rated capacity. That's an enormous savings right here.
A key prerequisite of a smart lab involves designing dynamic digital control systems for air volume, exhaust, thermostats, and other building automation systems.
This is the key technology. This is the brain of the system, which makes this building dynamic and keeps it safe. So what we have here is the controller for the air QD system. These little tubes you see here are carrying air packets that come from all the lab spaces on this floor. We actually have one of these air QD controllers on every floor of this building and similar buildings. And what happens is they're analyzed by these sensors for total VOCs, for particulates, for carbon dioxide and carbon monoxide. So since we're dealing with air changes in laboratories, we have a lot of data that makes sure that we can not just manage the energy, but do it in a way that's safe. Now, a key part of our energy team is our environmental health and safety staff. And the reason is, when we set out to deliver just the right amount of energy at just the right time, what we're doing is changing illumination levels and air changes. We're affecting the environment. And we want to ensure that that's done in a way that doesn't compromise anyone's safety at all. It's an absolute cardinal rule as far as we're concerned.
When possible, operators can safely reduce the change rate flow of fume hoods.
Here we have a fume hood designed according to SmartLab principles. Here you see a zone presence sensor which has increased the airflow for this hood as the minute I walked up and stood in front of it. You can also see that as I open the sash, you can hear that the volume increases and it goes back down. Now that's not just me closing the lid that you hear, it's actually reducing the volume. So here we are on the roof of Natural Sciences 2, and this is the end of the chain for air going through the building. You see the manifold that runs along the parapet of the building here collects all the risers of exhaust coming up through the building. Every building around here that I can see has had an extension on the stacks. That section on top where it looks kind of shinier, that's a new piece of looks like about a 3-foot extension. But believe it or not, that extension made it possible to cut the speed of those fans in half and to close the bypass dampers. The bypass dampers, which are big constant energy wasters. On this exhaust system here, by the way, there's an anemometer which, under rare condition, the wind will come from the opposite direction, right into our face here as we're standing here. And so that anemometer will sense that condition, and at that time it will increase the exhaust discharge velocity from those fans. So this is what we mean about a smart system. It uses sensors and controls to apply just the right amount of energy at just the right time, rather than, again, as opposed to going to the worst case condition and running at a fixed volume. It's a dynamic system. Part of a SmartLabs retrofit is to make the lighting system smart. The lamps are LED, and that saves about half. That savings can be increased a lot by also putting the lighting under the kind of control that offers occupancy sensing, vacancy sensing, daylight sensing, and has a trim adjustment so that when all these features together are used, the lighting system becomes smart enough that the energy savings approach 80%. So you see a light shelf up here about 3/4 of the way up the window. You see here we're using perforated blinds. There's still enough daylight to use, and it comes through with no glare. And the net effect of this, as you can see, the space I'm in has very limited artificial light. There's a daylight sensor right up here, which is cutting way back the amount of light that's coming out of this fixture right over my head. Here's an occupancy sensor which serves two functions in this lab bay of the SmartLab. It both controls air changes, so the air changes go way down to a standby level when there's no motion in this aisle, and it also controls the lighting in this lab bay.
With digital sensors, UCI created a proactive continuous commissioning plan that turns large volumes of data into meaningful analysis and actionable reports.
Nothing we've done involves esoteric or bleeding edge technology. It's just taking a comprehensive look at all the systems in a building that manage energy or use energy from the top of the building to the bottom of the building, and doing it in a synergistic, holistic way. We now have sensors and software that make it possible to make a building dynamic and to deliver just the right amount of energy at just the right time. And I give credit to a team of people working under me, which has in it very skilled technical people, very imaginative people, people willing to buck the status quo, to question all the assumptions that have been touted as best practices for not just years but decades. And because of that, we've achieved with our SmartLabs retrofit program over 60% total energy improvement.